Hi, I'm Christopher Pineda, and I work in the lab of Dr. Laura Burris here at San Francisco State University in California. Our lab studies the role of Wnt ligands in neural tube closure. In Wnt signaling, a producing cell will secrete Wnts, which then activate Fizzle receptors. This prevents the degradation of beta-catenin, which is a transcription factor. Once enough beta-catenin is accumulated, they will translocate into the nucleus and help activate certain target genes. I specifically work with Wnt5A because it is expressed before and after neural tube closure. We seek to identify the individual role of Wnt5A in neural tube closure, so let's take a closer look at that procedure. In order to investigate the role of Wnt3A and 5A in neural tube closure, we must first ask, well, what happens to the neural tube when there's too much Wnt around? In order to accomplish this, we must extract a 24-hour-old embryo from the egg using scissors and a slotted spoon. The first step is to crack the egg open. In order to see the embryo on the yolk, India ink is used to enhance the contrast. Using the scissors, we cut around the embryo and with the help of the slotted spoon, we are able to extract the embryo from the yolk and place it into a salt solution where we may manipulate it for growth. Once the embryos are placed in a salt solution, we then separate the vitelline membrane from the embryo. Using the modified Cornish pasting method, we manipulate the embryo by folding bilaterally with the dorsal side out. The folded embryo is then crimped and cut to seal the edge, creating a ventral pressure necessary for growth. The sealed embryo is then transferred to a petri dish containing a ratio of thin albumin and Wnt-conditioned media. This allows many embryos to be exposed to the same concentration. After a day of incubation, we then fix and section the embryos for further analysis. Manipulating the embryos so they may grow was one of the toughest challenges that I've ever faced. However, when they did start to grow, the feeling was unforgettable. I learned that no matter how tough a challenge can be, just to stick to it and never give up. 4 years ago, I would have never imagined myself being a part of a lab, let alone attending a university. My grandparents came from Nicaragua in search of better opportunities for the family. Being first generation and growing up in the Latin community of San Francisco, not many opportunities presented themselves. However, with the help of Mark and the Choose Development programs, I find myself in an environment surrounded by great students and mentors. My PI, Laura Burris, has not only made me a better scientist, but a better student. She has changed my life for the better, and I hope I can repay her one day. I am having the time of my life here in lab and look forward to the future. But now that I think about it, it looks like I may have found that better opportunity. Thank you for watching.